Assalamu alaikum everyone. How are you guys doing? वालेकुम सलाम. मरियम शुरू हो गई है. क्या हाल है आप लोगों के? So you guys had an exam today? October November students? Sir, Friday को add maths का पेपर है. वालेकुम सलाम. And how's the preparation? I know you guys have an exam. That's why I'm streaming this topic. I'm good. What about you? So you guys have an exam tomorrow? Yes or no? Which calculator do you recommend for CIE? This one right here, the one that I'm using. Not because I'm using it. It's just a calculator that has a lot of functions. It's Casio FX570EX. You must have seen me using this calculator in my live streams or in the videos. Okay, I've had this calculator for I don't know how long, for as long as I can remember, I think. So this is the one that I would recommend. Minus 100% preparation. Okay, that's interesting. No to what? Okay, no exam tomorrow. Yeah. Okay, so let's start, shall we? Not a good shot, Osama Mir. हाँ, ओरिजिनल बहुत महंगा है, बिल्कुल है. तो जब आप एक दफ़ा ले लें तो बेटा संभाल के रखिएगा उसको. ठीक है, थिंग्स हैव गॉटन रियली एक्सपेंसिव नाउ. सो सी इफ यू कैन get it from someone, like someone who doesn't need it anymore. I say I can't think of anyone who will not need a calculator. But I don't know, look around. Maybe you can buy a slightly used one. Maybe someone has a spare or something. Okay, so let's start, shall we? Now I know you guys have an exam on the 6th and I think paper 2 is on the 11th. कॉपी मैं recommend नहीं करूँगा. कॉपी में कभी कभी normal calculations भी नहीं होती. So that's why I will not recommend you get a copy. Buy it once, keep it safe, but buy original. Okay? ठीक है, तो पेशावर से मंगा लें. Sir, 6 का exam and I flu हो गया. What do I do? Received an email saying they won't let us. Okay. I really don't know what to say. 9th. Okay, 11th I think is math. I don't know. Speak to the British Council, see what they have to say. I really can't tell you what to do, except that get well soon. Okay. So once you guys are done with paper 1, do let me know what comes in paper 1 so we can use that to sort of anticipate what will come in paper 2. Okay. Acha, those of you who are watching and haven't liked the stream yet or subscribed to the channel yet, I would suggest you do that. I don't know why I have to ask every time, but it's okay if that's how it is. So I'm starting. All right. Now you will find this PDF in the description. Okay. In this, I have highlighted questions from easy, medium, hard to insanely difficult. Now, I'm going to be honest here. I did that in a rush. Okay. I did that just 25 minutes ago. Okay. So I might have maybe marked a question hard and it could be easy or the other way around. Okay. So either way, we're going to start off with some easy questions. Okay, so we're going to start off with some easy questions of trigonometric equations. So first of all, every time you're starting an exam that has a calculator, doesn't matter whether it's math or add maths or physics, just do one thing, make a habit of it, and that is reset your calculator. Okay, so we're going to start off with some easy questions. That means we're going to start off with some questions highlighted in green. Difficult questions stream when I will be covering difficult questions as well. Okay, I will be doing difficult questions as well. Don't worry. I plan on doing trigonometric equations, permutation, combination, vector. Yeah, these are the topics that I plan on covering. Okay. Okay, and I have done a lot of streams in the past as well. So if I don't stream off a topic you want me to stream, you want me to do a stream on, then you can watch maybe last year's stream. Okay, it's definitely going to help you guys. Anyway, so enough talk. Let's get to work. Okay, so 3 sine x minus 5 cos x equals to 0. So what are we going to do over here? This, yeah, of course, before the 6th. Okay, before the 6th or before the 9th. Okay. First things first, let's turn it into an equation where you have the trigonometric function on one side and a constant on the other side. Okay, so whenever you see sine and cos, you should realize that we might have to use tan somewhere. Okay, so what is tan x equal to? Tan x is equals to sine x upon cos x. So that means 3 sine x equals to 5 cos x. Okay, so I've shifted 5 cos x over to the other side. And now be very efficient with your working. Don't use a lot of space and don't start from the very center. Start from the left of the space that's provided to you. So this is what we're looking at. We're looking at sine x upon cos x, which is equal to 5 upon 3. Now what is sine x upon cos x equal to? That's equal to tan x. Okay, 5 upon 3, I would suggest that you keep it as 5 upon 3 only. Now look at the range of x. The range of x is from 0 to 360. That means there's nothing we have to worry about, and that is why I've classified this question in the easy category. Okay, so what's the next step? The next step is that we need to find out alpha. Okay, but before we do that, where are we going to draw alpha? Alpha will be drawn in the first and the third quadrant. And why is that? That's because tan is positive. So ASTC, I'm sure you guys remember that. All science teachers are crazy. So let's find out alpha, which is going to be tan inverse of 5 upon 3. Okay, so let's work this out. See what do we get. Tan inverse 5 divided by 3. So we're looking at 59.03. So we'll lock it at 59.0. So this is alpha. Okay. Now let's calculate theta, or x in this case rather. How are we going to do that? So we'll start from the positive horizontal axis and we'll go in a anti-clockwise direction, and we'll keep on going till we reach alpha. So here's 270, here's 360. So x is going to be equal to 59.0. That's one angle. And then what about this one? This one is going to be 180 plus 59.0. So we're looking at 239.03. So 239 is good enough. Remember, all angles are given correct to one decimal place. And there you go, fellas. That is your answer. That's it. I mean, that's not it, but yeah. Okay. Sir, can you solve the May June 2023 paper? No, I will not be solving past papers on the channel, because last time I did that I got a strike. So I will not be solving past papers. Okay, let me see if I can maybe record it, make a video of it, and then share it with you guys. Okay, but we don't have that much time. I would suggest the marking scheme is available. I would suggest you try and solve it yourself. Okay. Okay, now, so that's that. That was an easy question. Let's do another easy question before we do some slightly medium level questions. Now, what I really want to do are those questions where you have to alter the range. Basically, the questions that I've highlighted red, or the questions that I've highlighted yellow, or orange, in fact. Sorry, yellow are pretty easy as well. So let me find another easy question. Then we will do some medium level questions. Okay, so here's a question very similar to the previous question. Okay, it's only a slight difference, except, and that is, you won't have positive tan, you'll have negative tan. All right, so first things first, let's keep 3 sine x on this side. Okay, let's take 4 cos x across, so that's going to be minus 4 cos x. Let's bring cos x under sine x, so we have sine x upon cos x, which is equal to minus 4 upon 3. And what's sine x upon cos x equal to? That's equal to tan x. So tan x equals to minus 4 upon 3. Let's work out alpha, for which we will take tan inverse, but we'll take tan inverse of positive 4 upon 3. So that gives us 53.1 degrees. Okay. Now here, watch out, tan is negative. And where do we find tan negative? We find tan negative in the home ground of sine and cos. Okay, that's what I like to call them. The second quadrant, think of it as the home ground of sine. The fourth quadrant, think of it as the home ground of cos. Okay, so there you go, 53.1, 53.1. Here is one angle, which is going to be 180 minus 53.1. If you do that correctly, let's see what do we get. That is 126.86, so that's going to be 126.9 degrees. And then this angle, for this we will do 360 minus 53.1, so we're looking at 306.9, and that is the correct answer. Okay, so far there's nothing that's complicated, it's fairly easy. Okay, now let me read your questions. All angles are supposed to be given correct to one decimal place. Okay, all angles, walaikum salam, all angles are supposed to be given correct to one decimal place. Yeah, so you can't solve past papers on live stream, or if you get caught, they basically make a copyright claim out of it. Is it okay if we leave angles correct in degrees to one decimal place? So any angles in degrees are supposed to be given correct to one decimal place. Okay, other than that, your answer is supposed to be in 3 significant figures. Okay, so I hope I've made myself clear. Now, you won't find many of these easy questions. Most of the questions will be such that you have to use trigonometric identity. So that's what I plan on doing now. Let's do a question where we have to use a trigonometric identity, okay? And that is the very first question of this worksheet, which, by the way, is a past paper question. It's from May, June 2011, paper 12. All right, now, before you can solve a question where you have multiple trigonometric functions, you have to make sure, sir, this isn't for IGCSE normal students. What do you mean by normal students? So you're saying this is for not normal students? This is AdMaths, okay? Read the caption. Sorry, not caption, title. Yeah, read the title. This is AdMaths. Now, I don't know where you put yourself. Do you classify yourself as a normal student? Okay, you mean normal maths. Yeah, no, this is not for normal maths. This is for AdMaths. Okay. Now, let's get back to work. You help me understand composite function. Thank you, the United States Presidential Channel. Thank you for acknowledging my efforts. Anyway, let's get back to work. So, as I was saying, you have cot square cosec minus 1, 2 cot square x minus 5 cosec x minus 1 equals to 0. Now, one thing to keep in mind is that your calculator doesn't have anything other than sine, cos, and tan. Okay, so that means no matter what you do, no matter what kind of trigonometric equation you solve, you have to bring it down to sine, cos, and tan. Okay, so that's what we're going to do. We're going to bring it down to sine, cos, and tan, or maybe something that we can then express using sine, cos, and tan. Okay, so here's cot square, and you can see these identities, by the way, you don't have to memorize them, you will be given these identities. Cot square x can be written as cosec square x minus 1 equals to cot square x. And you can see that solving the problem, we will have a trigonometric equation in terms of cosec. So 2 as it is, cot square x gets replaced by cosec square x minus 1 minus 5 cosec x minus 1 equals to 0. All right, so let's expand this. So you have 2 cosec square x minus 2 minus 5 cosec x minus 1 equals to 0. All right, so this becomes 2 cosec square x minus 5 cosec x minus 3 equals to 0. Okay, what does this look like? What does this remind you of? This should remind you of a quadratic equation, because that's what it is. This is a quadratic equation in disguise. Okay, so that means we are going to use the concept of middle term breaking over here. Think of cosec square x as y. Okay, so this becomes 2y square minus 5y minus 3. So using the concept of middle term breaking, this is what we have. Factors of minus 6 that leave you with minus 5, minus 6 and 1. Minus cosec x plus cosec x minus 3 equals to 0. So let's take 2 along with cosec x common. So we have cosec x minus 3. And then let's take 1 common. Actually, there's nothing we can take common. That's why we say plus 1. So now I'm just going to skip a few steps. And actually, no, I will not skip a few steps. Let's just do it step by step. So we have 2 cosec x plus 1 into cosec x minus 3, which is equal to 0, which means cosec x equals to 1 upon 2, or cosec x is equals to 3. Okay. Now, what is cosec x equal to? Does anyone remember what cosec x is equal to? Yes, no? I'd like an answer. And by the way, this is going to be minus 1 upon 2, not positive 1 upon 2, minus 1 upon 2. Let me rewrite that. So cosec x is equal to 1 upon sine x. Okay. So that's what I'm going to do. I'm going to rewrite this. Yeah, minus 1 upon 2. I fixed it. Can you do 2 part 2? All right. Hold on. So cosec x is equal to, yeah, it's equal to 1 upon sine x. Okay, so here we are. That means 1 upon sine x is equals to minus 1 upon 2, or the same 1 upon sine x is equals to 3. Now this leads to the conclusion that sine x equals to minus 2. Now try solving this. Try finding out the value of x when sine x is equals to minus 2. You'll realize that you don't have any. And the reason for that is sine is always in between minus 1 to 1. So this is not possible. Try taking the inverse. You'll realize it's not possible. This, however, becomes sine x equals to 1 upon 3. And this is pretty much possible. So work out alpha by taking sine inverse of 1 upon 3. So we get 19.47 or 19.5. Then what are you going to do? This is what you're going to do. Sine x is positive. That means it is in the first or the second quadrant. It's home ground. A, S, T, C. Okay. Here's 19.5. Here's 19.5. So let's work out the value of x. In the first quadrant, it's going to be 19.5. Okay, now by the way, you have enough space over here. So let's do it over here only. So x equals to 19.5 for the first quadrant. And then for the second, we will do 180 minus 19.5, which is equal to 160.5. And there you go, fellas. That's the answer to part 1. Sir, will we have bearing questions in vectors? Yes, Fawaz, we will have bearing questions in vectors. Haven't you solved past paper questions yet? You should have solved past paper questions. Okay. And if you did, you would have realized that we do have bearing questions in vectors. Okay. The concept of vectors, the concept of bearing is very commonly found in vectors. All right, so far so good, I hope. What's my name? My name is Saad. Sir, हमारे पास vectors में bearing related. Yes, Mahat, yes, you will have questions. Solve the May June 2022 past paper, paper 2 variant 2. You will have a question related to, you'll have a vectors question with bearings in it. And there have been other past papers as well where you have questions related to bearings. Watch my stream, watch my vector stream from last year. And I've solved plenty of questions where this concept is tested. Sir, please, are we allowed to use calculators? Yes, you are allowed to use calculators that give you exact answers. Nothing to worry about. Okay, somebody requested a question. Let me solve that. Which one was it? Sir, 2 part 2. Okay, let me see. All right, so 2 part 2. I did plan on solving 2 part 2. Okay, so let's see what it says. So it says here, Sir, are we allowed to use calculators that give exact? Yes. I don't know how to pronounce your name, but yes, you are allowed to use that. Okay. Negative range wala bhi karenge, but first let's do some easy and medium level questions. Let's do some medium and hard level questions, then we'll do negative range as well. Okay. So step by step. All right. Now, let's see what it says. So this question says here, solve the equation 6 cos y plus sec y equals to 13 for 0 to 360 degrees. Okay. So it's a 5-mark question. That means there's a decent amount of working that's probably required to solve it. So sec, okay, sec is the trigonometric function that we need to somehow change. Okay, now what can we change sec to? Sec is something that can be changed to 1 upon cos. Okay, so that's what I'm going to do. I'm going to change sec to 1 upon cos. So 6 cos y, we'll let this be as it is, plus 6 upon cos y equals to 13. Okay, so there you go. Now we will have to take the LCM, and if I do that, let's see what happens. Let's see what happens if I take the LCM. So the denominator is cos y. Okay, we multiply 1 with cos y, and we multiply 6 cos y with cos y as well. So here's what we're looking at. We're looking at 6 cos square y plus 6 equals to 13. Okay. Now cross multiply. Let's see what do we get. 6 cos square y plus 6 is equals to 13 cos y. All right. Now I should have started my working from the left. Okay. So keep that in mind. Then we have 6 cos square y minus 13 cos y plus 6 equals to 0. Okay. Now middle term breaking. Factors of 36 that leave you with minus 13. 9 and 4, except that you will have minus 9 and minus 4. So 6 cos square y minus 9 cos y minus 4 cos y plus 6 equals to 0. All right, what can we take common from the first two terms? We can take 3 along with cos y. So open the bracket. Let's see what do we get. We get 2 cos y minus 3. Yes, you could have used the substitution as well. Okay, I generally don't like doing that because it just increases the amount of working we need to do, but you can totally do that. Okay, minus 2 cos y, which means in the bracket we have 2 cos y minus 3 all over again. Okay, sorry, not minus 2 cos y, just minus 2. Okay, so what are we looking at? Let's see. We are looking at 3 cos y minus 2 into 2 cos y minus 3 equals to 0. Okay, which means cos y is either equal to 2 upon 3 or cos y is equals to 3 upon 2. Now one of these two is not possible, and that is cos y equals to 3 upon 2. This is not possible because the value of a sine function or a cos function cannot exceed 1. Okay, so this we conveniently say not possible, and we bring our attention to cos y is equals to 2 upon 3. Now because it's positive, that means it could be in the first or the second or the fourth quadrant. Yeah, so it could be in the first or the fourth quadrant. Okay, let's work out the value of alpha, for which we will take cos inverse of 2 upon 3, which is equal to 48.18. So that means it's going to be 48.2 degrees. Okay, so here we have 48.2. Okay, this line is abnormally long for I don't know what reason. And here also 48.2. Okay, so one by one, let's start calculating the value of y. So y in the first quadrant is going to be the same as alpha. In the fourth quadrant, it's going to be 360 minus answer, which means 311.8. And that's the correct answer. There you go. Sir, please do ASP1 transformation. I have a video. I remember doing a live stream on P1 transformation functions. I know it's a challenging topic. I plan on doing more of it, but you should watch that stream. Okay, if you want help immediately, you should watch that stream. Okay, so how about we do a slightly difficult question? We do a question which is, yeah, let's do this one. So can you summarize important points about trigonometric graphs? I don't think that's possible, but I do pretty sure I have a video on it, which you can check. Okay, I can see what's behind me, Mahant. Okay, so let's do question number 22, part A. Let's see what it says. 2 cos 3x is equals to cot 3x. So what are we going to do? First thing we're going to do is we need to alter the range. Okay, something called alter the range. So we'll do part A and part B. Okay, altogether it's a 9-mark question and it is from October-November 2014. Yeah. So again, we have cos and we have cot. Okay, so your safest bet is to bring everything in terms of sine and cos. Okay, remember, whenever you're solving a trigonometric equation, your safest bet is always to bring everything in terms of sine and cos. Okay. What else? Sir, very difficult question. This one? No, this is not a very difficult question. This is a medium. No, wait. This is difficult, but not insanely difficult. Okay. Cot 3x. What can I do with cot 3x? Cot 3x is something that can be turned into sine and cos, right? Cot 3x is something that can be turned into sine and cos, except that it's going to be cos x upon sine x. So cot 3x can be written as cos 3x upon sine 3x. Again, make sure that you guys know the identities very well. Equals to 2 cos 3x. Okay. So let's cross multiply and let's shift everything over to the left hand side. So we have 2 cos 3x sine 3x minus, in fact, wait a minute, let's not skip a step, equals to cos 3x. Okay. Now don't cancel out cos 3x, because if you do that, you miss out on some very important solutions. Okay. So let's shift everything over to the left hand side. You have 2 cos 3x sine 3x. Okay. Minus cos 3x, which is equal to 0. All right, so now we're going to take common and we're going to solve. So what can I take common over here? I can take cos 3x common, which means we're looking at 2 sine 3x minus 1 equals to 0, which means it's either cos 3x that's equal to 0, or it's 2 sine 3x minus 1 that's equal to 0, which means sine 3x equals to 1 upon 2. Okay. Now, next thing you need to do is you need to alter your range. Now, the range that we have for x, the angle that we have is 3x. So that means we got to make sure that everything is consistent. Everything is in, the range is in line with the question. So we multiply everything by 3. Okay, so 0 times 3 is 0. 90 times 3 is 270. Okay, so this is going to be our new range. Now, cos 3x equals to 0. If you remember, these are some special values. Okay. And you can't use a calculator all the time in order to work this out. Why? Because your calculator might give you one value but not the other. So when is the graph of cos equal to 0? The graph of cos is equal to 0 at 90 and 270. Okay. So that means when cos 3x equals to 0, 3x is either equal to 90 or the same 3x is equal to 270. Now make sure that is inside the range, which it is. Okay. So because it's inside the range, we don't have to worry about it. Okay, everything is so far so good. Okay, so I hope you guys are following. Okay, next is sine 3x equals to 1 upon 2. Okay, let's see what we can do over here. Sine 3x equals to 1 upon 2. So we'll take sine inverse of 1 divided by 2. So we're looking at 30 degrees. Alpha. This we're going to solve like a normal question. Okay. So sine 3x is positive. That means it's going to be in the first and the second quadrant. So let's make alpha in the first and the second quadrant. So here we're looking at 30 degrees and here also we're looking at 30 degrees. Okay, so let's write these values down one by one, see what do we get. So this is one value. This is equal to what? So 3x equals to 30 degrees. All right, and here is another value, which is 150 degrees. Okay, now let's write down all the values together in one line. So that means we're looking at 3x equals to 90, 270, 30, and 150. Okay. Now, one thing to keep in mind is this. One thing to keep in mind is this. That there are some values which we will not accept. Okay, now just a minute. Let me tell you which values we are not going to accept. Okay, I'll tell you about that in a minute. So let's work out all the values of x, and then I'll tell you which values we're not going to accept. So this is 30. All right, so far so good. And then 270 divided by 3. Let's see what that is. 270 divided by 3 is 90. Okay, then 30 divided by 3, that's 10. And 150 divided by 3, it's 50. Okay, now let me see if there are any values that we are not going to accept. So let's write all these answers in an ascending order first. So we have 10, we have 30, we have 50, and we have 90 degrees. Okay. Now, just a minute. Let me see if do these type of these type of questions don't come in IGCSE Math. This is hard maths. So I think you included the lecture video of transformation in ASP1 in yearly past papers. So when do we alter the range and when should we not? Okay, let me answer that question. So we alter the range, first of all, when you have something like this. When the range that's given, it has a different coefficient of x and the angle that you're using is different. Okay, that is when we alter the range. So here the angle that we're using is 3x and the range that you're given is for x. Okay, so that is our cue to alter the range. Okay, now just a minute. Okay, so that's it. That is our final answer. Yeah, there you go. Now let's do part B as well. In part B, you can see that we have to alter the range. So let's see what the deal with that is. Okay. Now, before I solve part B, let me ask you guys a question, and that is, what is the one thing we need to watch out for in part B? What is the first thing we're going to do in part B? Question for you guys. Radian mode, yes. So the first thing you're going to do is you're going to convert your calculator in Radian mode. Okay. So let's do that. Let's convert the calculator in Radian mode. Yes, reciprocal and all of that part will come later. But first things first, and that is you need to convert your calculator in Radian mode. Okay, Fawaz, that's a nice display picture you have there. Okay, so here's what we're going to do. I hope you guys know how to do that. The exam's on the 6th. Pretty sure everyone knows how to do that. Okay, so sec is equal to 1 upon cos, all right? But this is going to be 1 upon cos y plus pi upon 2 is equals to minus 2. Okay, let me write this nicely. Looks hideous at the moment. So it's going to be 1 upon, okay? Now, okay, read the title. It says add maths. Now, why do you need to watch it if you're a math student? Okay. So here we have 1 upon cos y plus pi upon 2 equals to minus 2. Okay, so let's make cos the subject. Let's make the trigonometric function the subject. So cos of y plus pi upon 2 is equal to minus 1 upon 2. All right. Now that you have everything straightened out, the next thing you need to do is you need to make sure that you alter the range. Okay, because the range that we have and the range that we are given, the angle that we have and the range that we're given is of a different angle. So what do I need to do? Simple. I need to add pi upon 2 on all three sides of the inequality. Okay, on both sides of the inequality actually. So pi upon 2. So that means a range for y plus pi upon 2 is actually greater than or equal to pi upon 2 and lesser than or equal to 3 upon 2 pi. Okay. Now here's something I recommend, and I like to call this a sneak peek. Okay. Now what do I mean by that? Here's what I mean by that. Write down the approximate decimal value of this range. Okay. So at the moment it's in terms of pi. So let's see what the decimal value of pi upon 2 is going to be. It's going to be 1.57. Okay. Because, and I'll tell you why we're doing this. Because when we're solving it, we will get our answer in decimal form and the range is in terms of pi. So it will be difficult for us to see what is inside the range and what is outside the range. Okay. So let's work out 3 upon 2 pi, the decimal value for it. So that's going to be 4.71. Okay. So with these values in front of us, we will know which value to accept and which value to reject. Okay. Now, cos is negative. Let's work out the value of alpha before we do anything else. So in order to find out alpha, we will take cos inverse of positive 1 upon 2. All right. Keep that in mind. We will take cos inverse of positive 1 upon 2. So thankfully, we have this in terms of alpha. We have this in terms of pi. So that's 1 upon 3 pi. Okay. But there are some cases where you wouldn't have it in terms of pi, which is why writing down the approximate decimal value of the range is important. Now, because cos is negative, it is going to be in the second or the third quadrant. All right. So because cos is negative, it's going to be in the second and the third quadrant. Now, do keep in mind that we have a slightly different range. Okay. So this is 0. This is pi upon 2. This is pi. This is 3 upon 2 pi. And this is 2 pi. Okay. So let's measure this angle. This angle is going to be what? This angle is going to be, let's see. Here we have 1 upon 3 pi. Let's write that down. And here also we have 1 upon 3 pi. So this angle is going to be pi minus 1 upon 3 pi. So that's equal to 2 upon 3 pi. Now remember, the value that we're finding out is not of y. It's actually y plus pi upon 2. So that's equal to 2 upon 3 pi. That's one value. Okay. And then this value will be pi plus 1 upon 3 pi. So let's work that out. Pi plus 1 upon 3 pi. So what is that equal to? That's equal to 4 upon 3 pi. Now both these values are inside the range. Again, you can see the decimal values. The decimal value of this is 4.18. This is 4.71. And the decimal value of this, 2 upon 3 into pi, is 2.09. So this also is inside the range. Now the thing is, our range is only till 3 upon 2 pi. So that means I will not go another cycle. Okay, these are the two angles that we are going to get. Now what I have to do is I have to find out the value of y, which means this pi upon 2 will go over to the other side and get subtracted from both these angles. Okay, so 2 upon 3 minus 1 upon 2. So we're looking at 1 upon 6 pi. 1 upon 6 pi, here's one angle. And then 4 upon 3 minus 1 upon 2, 5 upon 6 pi. So these are your two values. There you go. Okay. What did I miss? So how many years of past paper should we do to ensure? There is no answer to that question. Okay. There is no answer to that question. You should do as many as possible and make sure that you're getting a decent score every single time. Okay, there's not a magical number. Yeah, I will do that stream inshallah this week. Don't worry. Sir, is an average of 65 marks in a math in add math yearly a good progress for a good grade? But have you been getting 65 over and over again, or is your score increasing? If your score is increasing and you've stopped at 65, I wouldn't recommend that. Okay, try and bring it up to at least 70-ish. Okay. Yes, Aswad, I plan on doing more streams, inshallah. Let's see what time allows. Okay, let's do a question Sir, do a stream in which you ask queries of all art math students before 6th. It's not a bad idea. That is not a bad idea. All right, let's do this question. Wait a minute. Let me find a question where we have to go on the negative side. Hang on. Those are the ones that really bother students. Okay, found it. This is from... Yeah, here it is. So notice how many marks this is? It's a 3-mark question. Okay, so that means maybe it's not that difficult. Let's see. Okay, so first things first. Here, we don't have to... The reason why this is a 3-mark question is because there's not a lot of working you need to do before you start solving it. Okay, it's already tan x, so it's already tan 3 phi. This symbol, by the way, is phi. 3 phi minus 4 equals to 1 upon 2. So that means you don't have to do any manipulation, any algebraic manipulation. Okay, so the next thing we're going to do is we're going to alter the range. Okay, because the angle that we are using in the question is 3 phi minus 4, and the range that we're given is for phi. So how are we going to do that? So we're going to multiply everything by 3. Okay, so 0 remains 0. This becomes 3 phi. This becomes 3 upon 2 pi. Okay, then we're going to minus 4. Okay, so we're going to minus 4 from all 3. So we have minus 4, which is lesser than or equal to 3 phi minus 4, which is lesser than or equal to 3 upon 2 pi minus 4. Okay, now again, as always, let's do a sneak peek. Now minus 4 is right in front of us. We don't need to worry about what it is, what it's going to be. But this is minus 2 point, no, wait a minute. 3 divided by 2 pi minus 4. So this is 0.712. Okay, approximately 0.712. Now, let me ask you guys a question. When angle is negative, in what direction do we measure it? Okay, so I'm going to start solving it and see if you guys can answer my question. When angle is negative, so can we first... No, you can't do that, because if you multiply by 4 first, and if you subtract 4 first and then multiply by 3, then it becomes 3 phi minus 12. Then 4 also gets multiplied by 3. Okay, so make sure that you multiply first and then minus. Okay. All right, so let's find alpha, for which we will take tan inverse of positive 1 upon 2. So let's see what that is. Anticlockwise. Are you sure about that? Tan inverse of 1 divided by 2, if your calculator is in radian mode, should give you 0.464. Yeah, that is what you should end up with. 4636, so 0.464. Yeah. In fact, since this is not the final answer, here's what I will do. I will take it correct to 4 decimal place. Anticlockwise? Are you guys serious? You guys have an exam on the 6th, right? If angle is negative, we go in a clockwise direction. Yes, if angle is negative, we go in a clockwise direction. What's wrong with you guys? Okay, now bear in mind that your range is actually from minus 4 to 0.712. Now in cases like these, I always prefer to draw 2 separate quadrants. Okay, 2 separate sets of quadrants. So here is one. This quadrant will be for the entirely negative range, and then let's just make a copy of this. This quadrant would be for the positive range. Okay, now how are we going to do that? Let me show you. So the negative range will be from 0 to not entirely 2 pi, not from 0 to minus 2 pi, but it's going to be somewhere before minus 2 pi. So here's 0. This is going to be minus pi upon 2. Okay, and this is going to be minus pi, and this is going to be minus 3 upon 2 pi, and this is going to be minus 2 pi. Okay, so keep your eyes and ears open. Notice that the range is from minus 4 to 0.712. Okay, now because tan is negative, Where do we find tan to be negative? We find tan to be negative in the second and the fourth quadrant. Okay, and what is alpha? Alpha is 0.463. Now, this questions like these require a lot of patience, okay? So don't rush into them. 0.463, 0.463. Now remember, this is negative range, so we're going to measure this in a clockwise direction. So one angle is going to be 0.463, but because we have gone in a clockwise direction, it's going to be minus 0.463. Okay, and the other angle is going to be pi plus 0.463, but because we have gone in a clockwise direction, it's going to be negative. So pi plus 0.463, so we're looking at minus 3.604. Okay, so these are the values of 3, 5, minus 4. Okay, this is not your final answer. We will add 4 and then divide by 3. But let's settle this as well. So here is 0, here's pi upon 2, here's pi. Okay, we don't need to go beyond that. Now, this is negative. That means it's going to be in the second and the fourth quadrant. All right. So here we have 0.4636 and here also we have 0.4636. Okay, this is for the range that is positive. Okay, so what we have done is we have divided the range into two, from minus 4 to 0 and from 0 to 0.712. So if I measure this angle, what am I going to do for this angle? I will do pi minus 0.4636, which gives us 2.678. And what are we going to do with 2.678? Are we going to accept it or are we going to reject it? No, ASTC will not change whether we go clockwise or anti-clockwise. It makes no difference. Okay, I don't get it why we have to use negative graph too. We are using negative graph because a range is such that it has some negative portion in it as well. Okay, so can you guys answer my question? What to do with 2.678? Keep or reject? Should I keep it or should I reject it? Sir, will you do live stream on advance? I will do it till the 9th. Till the 8th actually, yeah. Till paper 2. Okay, inshallah. Yes, we're going to reject it because this is outside the range. This is outside the range. So we're going to reject 2.678 and one by one we're going to find out the value of phi. So minus 0.463 plus 4 divided by 3. So that gives us 1.179, which we will lock at 1.18. Then minus 3.604 plus 4 divided by 3. That gives us 0.132. And then in the end, if you wish, you can write your answer in ascending order. 0.132 and 1.18. That's it. So what is the one thing to watch out for? In questions where you have a negative range, make sure to draw that negative part separately and the positive part separately. Okay, that is what you need to watch out for. Now let's do another question of negative range. So won't we add 2 pi to it? No. Okay, I think what you guys have done is you've just memorized and not really understood the concept. When do we add 2 pi? We add 2 pi when the range is such that it allows us to go beyond one complete cycle. Now, is a range such that it allows us to go beyond one complete cycle? No, it doesn't. So we're not going to add 2 pi to anything. Okay. O-level math mensuration मैं करूँगा, don't worry about it. Okay, it's in my list. इस week मैं करूँगा, पेपर से पहले करूँगा, don't worry. वो इंटरनेट का मसला हो गया था, which is why I couldn't go ahead with it, but I will do it. Okay, happy? So when do we know when to take both negative and positive range? Okay, we know that by looking at the altered range. All right, let me do another example question. Let me do another question where hopefully we will have a negative range. Just a minute. Let me look for a question where I know for sure that we will have a negative range. Hang on. All right, I think I found something. 54. Okay, here it is. Solve tan 3x equals to minus 1 for x minus pi by 2 to pi by 2. Okay. So first things first, we're going to alter the range and make it 3x by multiplying everything by 3. So we have minus 3 upon 2 pi, and we have 3 upon 2 pi. Okay. Now again, let's do a sneak peek. 3 upon 2 pi we just saw is 4.712. Okay. And minus 3 upon 2 pi will definitely be minus 4.712. Okay. So tan 3x is already equal to minus 1. That means we can go ahead and find alpha by simply taking tan inverse of 1. Okay, so if you take tan inverse of 1, you get 1 upon 4 pi. Okay, now because tan is negative, that means it's going to be in the second and the fourth quadrant. And what is a range over here? A range is minus 3 upon 2 pi to 3 upon 2 pi. So here's how we're going to go about it. We're going to take minus 3 upon 2 pi to 0 separately. Okay, or you can say from 0 to minus 3 upon 2 pi separately. And then from 0 to 3 upon 2 pi separately. Okay, so what we're going to do is this. We're going to divide our range into two. One would be where we take 0, and from 0 we go back to minus 3 upon 2 pi. Okay, and the other range would be from 0, where we go forward, to 3 upon 2 pi. Okay, so one quadrant dedicated to this and one quadrant dedicated to this. Okay, so I hope that makes it clear, that makes it easy for you. So here we go. Alpha, remember, is 1 upon 4 pi. Okay, keep your eyes and ears open. Now, as I said, because tan is negative, that means it's going to be in the second and the fourth quadrant. There you go. It's going to be second and the fourth quadrant. So this is 0. This is going to be minus pi upon 2. Now, why is this minus pi upon 2? Because it's negative. That's why we're going in a clockwise direction. This will be minus pi. This will be minus 3 upon 2 pi. We don't need to go beyond that. Okay. But if we had to, then a full circle would have made 0 equal to 2 pi. Okay. But we don't need to do that. All right, so let's mark 1 upon 4 pi here, and let's mark 1 upon 4 pi here. So here also let's mark 1 upon 4 pi. Here also let's mark 1 upon 4 pi. And this, by the way, will be 0, pi upon 2, pi, 3 upon 2 pi. Okay, now one by one, let's start calculating the angles. Okay, and remember, when it's the negative range, you will go in a clockwise direction, and the final answer will be negative. So let's start with the negative range. This is 1 upon 4 pi in value or in size, but the sign is going to be minus 1 upon 4 pi. Reason? What's the reason? The reason is because we've gone in a clockwise direction. And then this in value, we can work it out by simply doing pi plus 1 upon 4 pi. So in size, this is 5 upon 4 pi, but because we have gone in a clockwise direction, it's going to be negative. Okay. Now, do we have any other negative angle to worry about? No. So let's move on to the positive angle. So this angle in size, it's going to be pi minus 1 upon 4 pi. So pi minus 1 upon 4 pi. What is that? That's 3 upon 4 pi. Okay. And then let's talk about this one. So this, by the way, if you work this out, this is going to be 2 pi minus 3 upon 4 pi. Okay, now remember I said sneak peek. Okay, this is 5 upon 4 pi, which, by the way, is equal to 3.92. Now tell me, what should I do? And also, by the way, 3 upon 4 pi is 2.35. Which one should I take and which one should I reject? And why? Walaikum salam, Abdullah. Please don't spam. I would appreciate it. In fact, I think I'm going to have to put you in timeout now. So coming back to my question. What should we do with 5 upon 4 pi, which is 3.92? No, wait a minute. 5 upon 4 pi is not 3.92. 5 divided by 4 into pi. Yeah, it is 3.92. Sorry. Wait a minute. I think I've done something wrong. It's 7 upon 4 pi. Sorry. This angle 2 pi minus 1 upon 4 pi, that's 7 upon 4 pi, which, by the way, is 5.49. Okay, sorry, my bad. So this angle, okay, in the fourth quadrant is 2 pi minus 1 upon 4 pi, which is 7 upon 4 pi, which, by the way, is 5.49. Okay, now see if you guys can answer my question. You should be able to now. 3 upon 4 pi we will keep. Yes, you're right. Okay. But what are we going to do with 7 upon 4 pi? And while you're doing that, I'm one by one working out the value of x. So x is going to be minus 1 upon 12 pi. Then we will have minus 5 upon 12 pi. Okay. Yes, we take 3 upon 4 pi and we reject 7 upon 4 pi. Okay, so this we're going to reject because it has gone outside the range. So this is going to be 1 upon 4 pi. And now if you want, you can write your answer in ascending order. Okay, although it makes no difference, but this is your final answer. Okay, this right here is your final answer. Yes, Tahir, this stream will help you in P1, inshallah. Okay, let's do another question. Okay, let's do this one. This is a very recent question. It's from October-November 2021, paper 12. Please do live for AS level. Okay, let me know what topic. Let me know what topic you want me to stream. All right, let's move on to the next concept. Okay, let's see what the next question. Sorry, let's see what the next question says. So here's a question which says solve the equation cot 2x plus pi upon 3 minus under root 3 equals to 0. So we have cot is equal to what? Cot is equal to tan. Okay, so here's what we're going to do. 1 upon tan 2x plus pi upon 3, okay, close the bracket, equals to, so I've skipped a step, I've done 2 steps at once, equals to under root 3. Okay, now swap places of tan and under root 3, so this is what you will have. You have tan 2x plus pi upon 3, which is equal to 1 upon under root 3. Okay, now if you want, you can write down the rationalized form, makes no difference. Okay, now that you've done this, you can go one step ahead and find alpha, but remember you have to come back and alter the range. Okay, so let's find alpha, then we will alter the range. So 1 divided by under root 3, so we're looking at 1 upon 6 pi. Okay, let's alter the range one step by step, which means multiplying everything by 2 and then from it subtracting, adding pi upon 3. So minus 2 pi, this becomes 2x, this becomes 2 pi. Now let's add pi upon 3, pi upon 3, and pi upon 3. Okay, so minus 2 plus 1 upon 3. Let's see what that is. Minus 2 plus 1 upon 3. So we're looking at minus 5 upon 3 pi. Alright, 2x plus pi upon 3. And then 2 plus pi upon 3. We're looking at 7 upon 3 pi. Okay, let's do a sneak peek. 7 divided by 3 into pi, so we're looking at 7.33. all right, very important. And then minus 5 divided by 3 pi is minus 5.24. okay, so keep your eyes and ears open. All right, now because tan is positive, all right, and because we have a negative range as well, so remember what we do in cases like these. In cases like these, we treat the negative part separately and the positive part separately. So tan is positive, that means the first and third. Tan is positive, that means the first and third. Okay, A, S, T, C, A, S, T, C. Here's 0. Okay, here is minus pi upon 2, here is minus pi, here is minus 3 upon 2 pi, and here is minus 2 pi. Okay, Then here's 0, here's pi upon 2, here's pi, here's 3 upon 2 pi, and here we have 2 pi. Okay, we know what alpha is. It's 1 upon 6 pi. Here we have 1 upon 6 pi. Here also we have 1 upon 6 pi. And here also we have 1 upon 6 pi. Okay, so I hope all is well so far. Now let's one by one start finding out the value of x. Now remember, this is a negative range. That means we will go in a clockwise direction. So this angle in size, it's going to be pi minus pi upon 6. So let's figure that out. 1 minus 1 upon 6. So we're looking at 5 upon 6, which is 2.67. So it's inside the range. Okay, so this is what we're looking at. 2x plus pi upon 3 is equals to 5 upon 6 pi in size, but because we have measured this in a clockwise direction, that means it's going to be negative. Okay, now let's talk about this one. So this angle in size can be worked out by doing 2 pi minus 1 upon 6 pi, okay, which is equal to 11 upon 6 pi, but because we have gone in a clockwise direction, we will write it in minus, and this, by the way, is minus 5.76. So what do you suggest I do with it? Do I accept it or do I reject it? While you're answering that, let me work out these angles. So this is going to be 1 upon 6 pi, which is acceptable, and this is going to be pi plus pi upon 6, which means it's going to be 7 upon 6 pi. Let me, however, make sure of it. 1 upon 6 plus 1. Yeah, 7 upon 6 pi. Okay, which, by the way, in decimal is 3.66. Yes, that is the angle that we're going to reject. Okay, now be careful of one thing. Okay, notice a range allows us to go slightly beyond one complete cycle. Okay, our range allows us to go slightly beyond one complete cycle because it's 7 upon 3. That means it's 2 pi and a little more than that. Okay, now how do we find out the values of x in the next cycle? We add 2 pi in them. Okay, so that's what we're going to do. We're going to add 2 pi in them to see what we get. Okay, so let's see what happens if I add 2 pi to 1 upon 6 pi. Okay, so 1 upon 6 pi plus 2 pi, 1 upon 6 pi plus 2 pi is 13 upon 6 pi, which, by the way, in decimal is 6.81. Okay, so 6.81. What do you think I should do with it? Should I accept it or should I reject it? Okay, pay close attention. 6.81. Is it inside the range or is it outside the range? Trigonometry, graphs for ad maths. Okay, let's see what all I can do. How many requests I can entertain before the exam. Yes, so this we're going to keep. Okay, now that's it. What we have to do now is one by one we need to write down all the values of x. Okay, so this part you can do in your calculator. You don't have to show all the working for this. So minus 5 upon 6 plus minus pi upon 3 divided by 2. I'll work this out, and you don't have to write pi every single time. Okay, just write it without pi. You're looking at minus 7 upon 12 pi, and when I say you don't have to write pi every single time, I mean not in your calculator. Okay, you can write it separately. All right, now what did we decide? Minus 11 upon 6 pi, we're going to reject it, so let me cross that out. Okay, now let's deal with these three. Okay, let's deal with these three. 1 upon 6 minus 1 upon 3 divided by 2, so that is going to be minus 1 upon 12 pi. Okay, now 7 upon 6 minus 1 upon 3 divided by 2. So that's going to be 5 upon 12 pi. Now 13 upon 6 minus 1 upon 3 divided by 2. So that's 11 upon 12. 11 upon 12 pi, yeah. And this is your final answer. So this was quite a challenging question, and sadly these questions are just 4-mark questions. I know you would like them to be more than that, but that's how it is. Okay, sir, is it important to change the range? Can't we just take out the final? No. You have to change the range. Yes, you have to change the range. Okay, this was an insanely difficult question. And everything from now on should be, I think, what, downhill? Not that difficult. When do we know which quadrant to take? Sometimes we take the second and the fourth for a tan question. That is when it's negative. When it's negative, you take the second and fourth. When it's positive, you take the first and third. Okay, know the quadrants. Know your quadrants. A, S, T, C. In the first quadrant, all trigonometric ratios are positive. In the second, sine is positive. In the third, tan. In the fourth, cos. Okay, that's how we decide. Okay, how about you guys solve this? Solve this. I will give you, well, take as long as you want. No, you don't have to add 2 pi to the negative value. No. You don't have to add 2 pi to the negative value. If you do that, you will end up with the positive values, okay, which we found using the quadrant anyway. Yeah, ASTC, add sugar to coffee, or all science teachers are crazy. Graph question. Okay, let's get through this first. Yes, Fawaz, let's hear it. Okay, let's just stick to trigonometric equations in this stream. In the next stream, inshallah, I'll try and cover graphs as well. And by the way, I've done a stream on it already. I will strongly suggest you guys check it out. Okay, but if I find the time, I will do a stream on graphs as well. Don't worry. At the moment, I'd like you guys to solve this. Okay, so anyone who has the answer and would like to share it? Is math paper 2 easier than art math? Depends on your level of preparation, honestly. Pi upon 6 and minus pi upon 3. Okay, let me solve it now. See what's what. First of all, write this nicely. So you have sine 2 phi upon cos 2 phi, which is equal to under root 3. Okay, which means tan 2 phi is equal to under root 3. Now you alter the range. That means you multiply everything by 2. So this becomes minus pi. This becomes 2 phi. And this becomes just pi. Okay. Yes, if you're an AS student, you can watch this. Okay, there's no harm. Alright, so let's find out alpha. Make sure your calculator is in radian mode. So we will do tan inverse of under root 3. So that gives us 1 upon 3 pi. Now we all know what pi is equal to, right? We know the approximate value. It's 3.142. So I don't have to write that down. Now because it's negative as well as positive, so we will have two separate quadrants for it. One will be from 0 to minus pi and the other would be from 0 to positive pi. Okay. So here's 0, here is minus pi upon 2, and here is minus pi. Here is 0, here is pi upon 2, and here is pi. Now what is alpha? Alpha is 1 upon 3, and because tan is positive, that means we will draw it in the first and the third quadrant. Okay. Remember A, S, T, C, A, S, T, C. There you go. Okay, so here we have 1 upon 3 pi. Here also we have 1 upon 3 pi. Here we have 1 upon 3 pi. And here also we have 1 upon 3 pi. Okay. Alright, I think most of you are giving the correct answer. So let's start from here. This in size, this angle in size is going to be pi minus 1 upon 3 pi. So let's work that out. 1 upon 3, 1 minus 1 upon 3. So we're looking at 2 upon 3 pi. Now this is a no-brainer that this is going to be outside the range, because this is definitely going to be greater than pi, okay, or you can say lesser than minus pi, which is going to be outside the range. Okay, so we're not even going to bother. This is going to be 1 upon 3 pi, and this, by the way, will be negative because we've gone in a clockwise direction, and this again is a no-brainer that it's going to be outside the range because it's going to be more than pi. So now we can find out the value of phi, which means minus 1 upon 6 pi. And no, wait a minute, minus 1 upon 3 pi, yeah, minus 1 upon 3 pi, and positive 1 upon 6 pi. And that's it. That's your final answer. Okay, the live stream is about to end. This was the last question. How did you get pi upon 3? Okay. First quadrant, what is x equal to, or the angle equal to in the first quadrant? It's the same as alpha. Is IGCSE Math? They're both the same. Anusha, they're both the same. Okay. There is not a major difference. Sir, do an AdMath stream on graphs tomorrow, all exponential, logarithmic, trigonometric. Okay, I will try and do it tomorrow. I think I have a stream for math lined up, maybe. Okay. How did you get the negative value? Okay. So for negative value, we make a separate range and we go in a clockwise direction. So what will this angle be in size? We will do pi minus 1 upon 3 pi. So that's 2 upon 3 pi. But because we've gone in a clockwise direction, it's going to be negative. Okay, so I hope that answers your question. So that's it for today. I will stop here. See you guys, inshallah, in a different stream tomorrow, maybe. Good luck for your exams if you have one tomorrow. Drop the link for graph. Okay, just search AdMath graph Mathlete. Okay, you will find something. Okay, so take care, everyone. See you soon. Allah Hafiz.